Have you ever really stopped to think about how everything in nature is constantly making decisions? I mean, from a tiny little plant to the massive weather systems, it's all about cause and effect, right? Conditions and responses. So what if we could teach our code to think in that exact same way? To adopt, to respond, and to make smart choices, just like the world all around us. Well, let's dive in and see how we can do just that.
You can think of this as nature's logic. I mean, a plant doesn't sit there and think about it, but it responds, right? If there's light, it grows that way. If it's too hot, an animal finds some shade. These are really simple conditional rules that, when you put them all together, create these incredibly complex and, frankly, intelligent behaviors.
So that's the big question, isn't it? How do we take this beautiful, simple, yet super powerful logic and actually build it into our code? How do we get our programs to be adaptive, responsive, and, well, to be smart?
Okay, so we're going to start with the most fundamental building block for making decisions in code. This is the simple two-way choice. In Python, we do this with something called if-else.
Now, the fancy term for what we're doing here is control flow. And honestly, it's a great name because that's exactly what's happening. We're controlling the path our program takes. Instead of just running straight from top to bottom, line by line, we're creating forks in the road. We're letting the program choose its own path based on the information it gets. At its core, an if-else statement is just a simple binary choice. It asks one single question that can only be answered with true or false. If the answer is true, the program does one thing. If the answer is false, it does something completely different. It's that clear fork in the road we were just talking about. And you can see just how clean this looks in Python. You've got your if condition, which ends in a colon. Then the next line is indented. That's your true path. Then you have the else with its own colon, followed by the indented false path. Now that indentation, it's absolutely crucial. In Python, it's not just there to look pretty, it's part of the actual rules. It's how the program knows which instructions belong to which choice. So, what kinds of questions can our code actually ask? Well, it uses these things called comparison operators. Just think of them as the vocabulary for our questions. They let us compare stuff. Is this number bigger than that one? Are these two words exactly the same? These symbols are the tools we use to build those true or false questions for our if statement. All right, theory is one thing, but the best way to really get this is to see it in action. So let's build a really simple program that solves a common, everyday problem. We're going to code a little helper that decides for us whether or not we should grab an umbrella on our way out the door. And it's all going to be based on one simple piece of data, the percentage chance of rain. Okay, here's the code. So on the left, you can see we ask the user for the chance of rain. Then comes our big decision. If chance of rain greater than 50. Now look over to the right where the program's running. The user types in 40. The program gets that and thinks, okay, is 40 greater than 50? Well, no, that's false. So it completely skips the first instruction and jumps straight down to the else part and prints no need for an umbrella today. See? Perfect, simple logic. That's great for a simple choice, but let's be real. Life is usually a lot more complicated than just a simple yes or no, right? What happens when you've got 3 or 4 or even more possible outcomes? For those kinds of situations, our code needs a bit of an upgrade. We need a way to handle a bunch of different options, and that is where the if-elif-else chain comes in. Let's jump back to our nature analogy for a second. That plant, it's not just thinking about light, right? It's also checking for water and nutrients in the soil and how hot it is. Its logic is actually a sequence. If the soil is moist, great, absorb nutrients. Else if the sun is way too strong, okay, conserve water. Else, as a last resort, maybe grow some new roots. It's a whole chain of decisions. And that is exactly what if-else does. Elif is just a short, handy way of writing else if. So the program checks the first if condition. If it's false, it just moves on to the next elif. It keeps going right down the chain until one of these conditions is finally true. And as soon as it finds one, it runs that block of code, and this is the really important part, it immediately exits the entire chain. It doesn't even look at the rest. That else at the very end, that's your ultimate safety net. It only runs if every single condition above it was false. Okay, let's put this new, more powerful logic to the test. We're going to build a little tool that can make a much more nuanced decision. So, imagine a farmer whose harvest quality totally depends on how much rain they get. It's not just good or bad, right? It could be excellent or good or just poor. This is a perfect job for an if-else-else chain. Now, the most important thing to see here is the order of our checks. Watch what happens. The user enters 70. The program starts right at the top. Is 70 greater than 100? Note, that's false. So it moves to the next condition. Is 70 greater than or equal to 50? Ah, yes, that's true. So it prints harvest is good. And because it found a true condition, it stops right there. It never even looks at the else part. This is why the order you write your checks in matters so much.
Whew, okay, we've gone from super simple choices all the way to complex decision chains. So let's just boil this all down to the absolute essentials you need to remember. If you're going to remember anything, remember these 4 things. First up, conditional statements. If, elif, and else are your basic tools for creating those decision points. Second, comparison operators. These are the symbols like the greater than sign and the double equal sign that you use to ask your true or false questions. Third, indentation. Remember, in Python, it's not just for looks, it's the law. It defines your logic. And finally, the if-elif-else chain. This is your go-to tool for handling multiple conditions in a clear, ordered way.
So, we started this whole thing by looking at nature's logic. And now, you actually have the tools to build that same kind of logic right into your own code. So I'll leave you with this question. Now that you know how to make your code smart, what small, everyday problem in your own life would you solve with it?